Good morning. I am D. Sengotin, Assistant Professor of Physics, SNS Technology, Coimbatore. Today we are going to study about magnetic materials. So basic terms and definition of magnetism. So first we are going to study about magnetic dipoles, a system consisting of two equal and opposite poles separating a small distance, that is magnetic dipoles. Then the dipole moment or magnetic moment associated with the magnetic dipole or a magnet, it is the product of force strength and length of the magnet, that is capital M equal to M into L. So small m equal to magnetic force strength and L equal to length of the magnet. Then the magnetic field, when a material placed in a magnetic field, the space around the magnet or the current carrying conductor where the magnetic effect is felt, that is called magnetic field. Then the next important line is magnetic force, then magnetic lines of force. So magnetic field is assumed to consist of lines of magnetic forces, which is defined as continuous curve in the magnetic field. So the diagram shows that the north pole and south pole, the lines of force passing towards south pole. So the amount of energy, the amount of magnetic forces depends upon the applied field. So magnetic flux, total number of magnetic flux, total number of magnetic lines, bunch of lines or group of magnetic lines of forces are called magnetic flux. So the next is magnetic induction or magnetic flux density B, the number of lines of force, magnetic force passing through the unit area of cross section A. Then magnetization, intensity of magnetization, it is the process of converting non-magnet to magnetic material. So the symbol used by intensity of magnetization I. So I equal to magnetic fold strength and the magnetic fold strength or magnetic moment per unit volume. So first of all, we know about the magnetic field, the magnetic lines and the magnetic lines of force. Then now magnetization, then intensity of magnetization. Then the next important question is magnetic susceptibility, high M. The susceptibility is a ratio between intensity of magnetism I and magnetic field intensity. So we already know that I equal to the process of converting non-magnet to magnetism, magnetic material. The magnetic field intensity is called the amount of force experienced by the magnetic material, that is ratio between I by H equal to magnetic susceptibility. The diagram shows that the first diagram, the material placed in the magnetic field, lines of force expelled from the material. The second diagram shows that the lines of force passing through the material. So it totally depends upon the amount of force passed, then amount of force experienced by the material. So depends upon the nature of the material. If we placed diamagnet, the lines of force did not pass through the material, then the material placed in the magnetic field, all the lines of force passing away from the material, that is called non-magnet, not having permanent magnetic moment. Then the second diagram shows that the lines of force passing through the material, that is paramagnetism or ferromagnetism. So in case I by H, high M value is positive, that is magnet, that is I by H equal to negative, is called non-magnet or diamagnetism. The next is magnetic permeability, ratio between magnetic induction and magnetic field intensity, that is mu equal to P by H. So the magnetic susceptibility is I by H, permeability mu equal to P by H. So P equal to magnetic flux density, so B equal to total number of lines passing through per unit area. So divided by H equal to the amount of force experienced, that is called magnetic field intensity. So finally mu equal to ratio between P by H. Okay, so in magnetism, the first line about magnetism, magnetic field, then magnetic lines of force, magnetic flux density, field intensity, then intensity of magnetization, then finally classification of magnetism or magnetic materials. So basically we are having two different types of magnetic materials, that is first one is not having permanent magnetic moment, the second one is having permanent magnetic moment. Then the example for not having permanent magnetic moment, that is diamagnetism. Then having permanent magnetic moment, that is example, first one is paramagnetism, the second one is ferromagnetism. And also the two different types of materials, that is antiferromagnetism and ferrimagnetism. Okay, now we are going to study about only diamagnetism. The material, the first diagram shows that H equal to 0, that means magnetic field intensity is equal to 0, the amount of force experienced by the material is equal to 0. So the second diagram shows that all the electrons, atoms or molecules will align perpendicular to the applied field H. Then the force is expelled from the material, that is called non-magnet, that is perfect diamagnetism. And the properties of diamagnetism: no permanent dipole moment, so repel the magnetic lines of forces, negative susceptibility. So already we studied in the previous slide, the susceptibility is negative, totally negative values, that is -1, -2. The permeability is less than unit. And also susceptibility is independent on temperature and on magnetic field strength. Okay, the next one is having permanent magnetic moment. The example for permanent magnetic moment, the first material is ferromagnetic materials. So the material which acquire weak magnetism in the same direction as that of external field. So that the first diagram, H equal, without field H equal to 0, so electrons spin alignment is different direction, random directions. Then the second diagram, H is left to right, the field is applied left to right direction. So the as well as the electrons will align parallel to the applied field direction. Almost 80 or 70% of the electrons moving towards applied field direction. Then the properties of magnetic moment: possess permanent dipole moment, attract the magnetic lines of forces, exhibit positive susceptibility, that is very important property. So in diamagnetism, that is negative susceptibility. In paramagnetism, almost positive susceptibility. Permeability is electric higher than 1. Then the susceptibility of the material C equal to C by D. C equal to Curie temperature divided by T. Okay, the next one, finally we are going to study about ferromagnet, that is very strong magnet. So we studied in the previous slide, there are three different kind of classification. The first one is not having permanent magnetic moment, second one is having permanent magnetic moment. So not having permanent magnetic moment, example diamagnet. Then having permanent magnetic moment, first example is paramagnetism. Then second important thing example is ferromagnetism. So material which acquire very strong magnetism in the same direction as that as an external field. So the first diagram shows that without field H equal to 0, so electrons align at any direction, random direction. If the field is applied left to right direction, so all the electrons will align parallel to the applied field direction, that is very strong magnet. Already we studied in the previous slide dia and paramagnetism. Dia is not having permanent magnetic moment, but para is 60-70% will align parallel to the applied field. But ferro is very strong magnet, that is all the electrons, all the atoms or molecules supported will align parallel to the applied field direction. Then the properties of ferromagnetic materials: so possess permanent dipole moment, attract the magnetic field strongly, permeability is more than unit. And then spontaneous magnetization, it is very strong magnet. So susceptibility is positive, it is very high.